live, so whenever you want to go.
Okay. Okay, welcome to our weather discussion for today. It's going to be abbreviated, we have a smaller crowd.
Let's turn off this overhead light too. It's the
Which
middle.
one is that?
Middle.
Okay.
That should be a qualifier question.
Yeah.
But we don't do the qualifier.
Yeah. No, we don't, that's correct. So we're watching an infrared weekly movie of what's been going on across the Atlantic and the continental U.S. I think this is among the stormiest periods that I've ever seen in this depiction. It's one after another. Look at, this was a big storm, and we're already halfway through the animation. Early on, you're going to see something crash into the Labrador Sea. Watch this. Right in here, look at those little swirlies, all connected. If we had a better, less oblique view of that, you'd see, I think, 6 little disturbances in the water vapor in a string. It's like a string of pearls. Absolutely beautiful. And then it doesn't stop. It's one after another of all these disturbances, many of them moving slightly westward. Because remember last week we had this big upper trough here that had little disturbances coming through it. This was one of the bigger ones among those. Here's another one. And they were just kind of getting recycled in this broad region of the Atlantic. Just absolutely beautiful. Look at that, 1, 2, 3, 4, 5, 6. So take a look at that on your own if you haven't seen, if you couldn't see it quickly like that. Incredibly stormy. And it's not just the Atlantic basin. I think, can we go to the Pacific one, Pete? Because I won't say anything in detail about any of these, but just watch what you see in the Pacific for the same period of time. One, two, I mean, numerous disturbances off the Pacific Northwest. It's been raining like crazy, snowing at high elevation. It's going to do that again in California this weekend. And then there's a big disturbance out to the west of Hawaii. Look at these. They're all over the place. It's just almost countless numbers of small and medium-sized cyclones in a very, very energetic, very stormy period in both of the ocean basins of the Western Hemisphere. I think this is really, really interesting. And the reason I'm kind of particularly interested in it is I've been thinking about stormy months of March and what they mean for the rest of the spring, the transition from winter to spring. This probably is going to qualify as a fairly stormy month of March. We're 10 days into it now, and if these two ocean basins, and everywhere north of about 25 degrees north, is any indication, excluding the high latitude, Arctic, if this is any indication, I have a feeling this is going to be one of those stormy months of March. And so, kind of collecting them right now to try and see what stormy ones look like compared to non-stormy ones, and then thinking about April and May too, and what's the downstream consequences of that. But there's reason to believe that there's something unusual that goes on the whole northern hemispheric circulation scale to produce such behavior at the end of the winter. And I'm kind of trying to figure out how we might test those ideas. So anyway, this is the last week or so has been a really great example of really stormy flow in the middle latitudes of the western hemisphere, at least in the northern hemisphere. So really interesting. Just everything's been spinning up. And look at it, one there, one there, one there.
That little cold air.
Look at that little
comes
thing.
down.
Yeah, and then there's cold air behind them all.
It's like giant bookend vortices or something. This
Yeah, yeah.
crazy. It just pushes this front to the west.
It's just amazing. Okay, last week we had Andrea Lang was telling us about look at that, like you said, Pete. Andrea was telling us about the sudden stratospheric warming, kind of close to the end of the season for the stratospheric polar vortex, but not quite. It's about a month away from the end. So there's all sorts of interesting things going on right now around the globe. But I have not had the time to prepare anything more than what I'll tell you about with respect to our snowstorm, which was pretty good, actually. I thought it was going to be another one like maybe it was 2 weeks ago, where it was predicted to be 2 feet of snow in Minneapolis, and they got 8. I had a feeling, based on what I was seeing on the upper level charts, that it would kind of go the same way, but it didn't. And so I've got a few things to show you, not that I have answers, but a few things that I want to show you that were available for the picking and maybe a little bit of discussion. So let's go first, Pete, to our current satellite movie over the continental United States. So here we are, and as you can see from the prior couple of animations, it's been a stormy week. And we're now looking at the high cloud deck associated with the thing that whisked by us overnight last night. It's all to the east. And then there's this separate feature, I think, on the southern edge of the subtropical jet that is over the Carolinas. And then a really pretty beastly cyclone that got itself organized over the last couple of days off the Oregon-Washington coast. It's finally made its way inland, and that continues to bring rain to the Puget Sound. I think it's finally clearing out in the Portland area, but then it's probably precipitating, if not just cloudy and miserable, over parts of Montana, Wyoming, Idaho, and Utah. And so pretty interesting picture. But you'd look at this if you didn't wake up with a shovel in your hand today and say, well, I guess it was just kind of been a boring couple of days in Madison, but it's really not. So let's take a look at the current radar too. And all of the semi-organized precipitation, and I'd say this is the part that's a little bit better than semi-organized over New York State and Pennsylvania. This is widely scattered showers. And we had snow this morning from 6 to 8 o'clock, and it was snowing moderately here in town. So that was on the far western periphery. Maybe it was these cells now that we're several hours past, but those few on the far western periphery of this kind of broad but not so well put together circulation that are kind of decaying away to nothing. I don't really know if they ended up with the extra inch or two that was forecasted for this morning in the lake counties of the state. I doubt it. It doesn't look like the reflection.
Mitchell Field in Milwaukee, which is on kind of the southwest side of Milwaukee at 10.1.
Oh, so they ended up with that much more than us.
Yeah.
We had 5.3 on the 9th. I don't know what our total was for this whole thing, but I bet it was like 7 or 8. I had about 8 at my house.
Yeah, and anywhere from 3 to 7, depending on where you were.
And it was quite interesting, too. We were talking about it on the way over to class because, you know, we were talking about radiation in 100. And we had a deep snow deck that fell all at once, of course. And then the ground's been warm. We've had it warmer than normal March already by a couple of degrees. And it's already the warm time of year. And so huge amount of infrared energy in the ground. And it melted that bottom layer of snow. So if you put a shovel to your snow on your driveway, there's all slushy on the bottom.
Yeah.
There's no other way to explain that except it's infrared absorption to non-existence for the snow. So it really did it. Okay, so what I'd like to do is take a look at 0Z yesterday and 06Z this morning from the perspective of quasi-geostrophic omega. But before I do, let's take a look at the upper level charts. And I think I'd like to see 0 and 12Z at 500 millivolts if I can be. So we probably need the Super Pete movie. The book is better, but the movie is worth going to see.
You want what level?
500. And then let's go to 0Z on Friday. 0Z on Friday. See, now I can say that. That's fine. So this, when I saw this map this morning before the 12Z came in, I thought, yeah, that's really interesting. And you might say, why is that so interesting? Geopotential heights in black, red every 5 degrees is isotherms. Look at the perfect phasing between this kind of strongly negatively tilted trough axis, and it's kind of, it's not really a robust trough, but there's a decent ridge downstream over Lake Huron. And then the phasing of the geostrophic winds and the isotherms. So there's cold advection going on in this region of cyclonic shear. So that tends to depress the tropopause right in this region, probably helps to produce a decent upper vortex structure. I'm guessing that would be a linear vortex structure. And then with the downstream ridge in place, quite independent perhaps of how this has all gotten itself organized, you do have the opportunity around 6 p.m. last night or 7 p.m. last night to have a sort of bulbous region of vorticity at 500 millibars right over eastern Iowa. Perfectly positioned for us here in southern Wisconsin to get a decent amount of forcing for upward vertical motion, even though that's a really weak little wave. Now, let's go just to the next one, to 12Z this morning, by which time, as we just saw, everything about that structure has moved well to our east. It's centered now, the upper trough geopotential minimum is now centered over, I don't know, western Michigan. And you've got still a pretty decent baroclinic zone on the backside. Still there's cold advection and cyclonic shear there, and so that's probably continuing to push the tropopause down over northern Illinois. So this upper trough will get a little bit more intense, is my guess, by the time we get to 0Z tonight. However, it was only beginning to intensify as it came across us. And that made me think, thinking back to the thing 2 weeks ago, oh no, this is the same old story, a linear vortex structure. It's interesting, there's no lack of interest there, but they're not usually potent for producing substantial precipitation. It just won't last long enough, there'll be no cyclogenesis associated with it, and so on. So, I want to just show you a couple of things that go along with that progression. The slight, well not slight, but reasonable development at 500 millibars. Not very much development at sea level yet, but sustained vertical motions streaking across the southern part of our state. And that gave us 8 inches of snow. I think it's our biggest event of the whole year. And coming from what looks like really innocuous little conditions. Just to be complete for this morning, there's our upper trough at 12Z this morning off the Pacific coast. Minus 33 just outside Portland at 500 millibars. That's really cold. So It's been cold over the eastern Pacific for this whole last couple of weeks, 15 days or so. And here's just one, yet another upper trough. This one has a really interesting history. We won't talk about it today, but it sat off the coast for the last 2 days, just sitting there spinning. If you look at the satellite picture, it's really quite dramatic. So this is a bunch of waves getting to about the latitude of what, 38 degrees north, and then they can't go any further south right now. It must be the jet axis or something. And so they're just progressing across the continent. And there's little warm-ups that come along when they first make it across the Rockies. We warm up, and then when the depths of the cold air comes across, maybe you get a development like we did on Thursday night into Friday. Can we look at 700 millibar speed at just at 12Z? So here's at 700, pretty decent geopotential height minimum, but roughly the same structure, a baroclinic zone stretching back to the west and the northwest. Generally cold advection on the western side, not really strong or very well concentrated warm advection on the eastern side at 700 millibars, but a decent circulation. Green Bay has the rogue wind out of the southeast at just a zephyr out of the southeast. Everything else looks like a pretty coherent circulation. How about at 850? There's 850. Maybe we will want to go back to the prior one in just a minute. But at 850, you'd be hard-pressed to find any semblance of a warm frontal structure or anything that even looks frontogenetic in this region over southeastern Ontario and parts of Quebec. Not so hard to find concentrated cold advection, which suddenly becomes zero advection. So there's cold frontogenesis in there at 850. But that's all associated, I think, with the cloudiness we saw draped across the southeast U.S. But really, how does one explain the cloudiness in Pennsylvania and New York, which appeared to be breaking up in terms of the radar elements, precipitation elements? It's not really well forced. And one of the things that I thought, looking at the prospects for this thing on Wednesday afternoon and then heading into Thursday was, oh, this is going to be the same as that Minneapolis thing. No frontogenetic activity to speak of in the lower troposphere. Forget it. We can't get a big snow out of that because this thing is just racing across the southern part of our state at upper levels, and it's developing as it does so. So I don't think it's going to be a good snow. I was dead wrong. So I found it pretty interesting what actually seems to have occurred at a first glance. Okay, so maybe we'll go to 300 millibars, and then we'll come back to 850 at 0Z if we can. So not surprisingly, when you have that kind of upper trough structure where the trough is over Michigan and you've got the baroclinic zone heading back, you have the jet kind of stronger on the western side of a broad bowl-shaped upper trough. That's not at all surprising. And right in this location this morning at 7 a.m., you're at the jet exit region. It's a reasonably strong gradient of speed right there over the Mississippi River in Illinois and Missouri. So there was some competing forcings here. The jet exit circulation here would be to force the air to rise, and then it's a broad sort of negative vorticity advection and ridginess into troughiness here. There's not much curvature, so the curvature is working against you, but not strongly. And I think that might have been why we were able to sustain some showers this morning in the form of snow. Because you have competing effects. The curvature is tending to force subsidence here. The speed change is tending to force ascent over southern Wisconsin, and I think that was a little bit stronger forcing given the orientation of the jet. But look at how right across about that latitude, 38 degrees or so, it's one little wave after another on this jet until you get it. And in fact, I think this is just a function of the weird projection. That probably goes more or less zonally into parts of the central Atlantic. So it's a little ribbon of weather systems that are kind of being carried along across central North America, northern North America by this jet structure. So that's interesting. I guess I do want to see the 0Z last night 850 map, Pete. Because I think even at that time, one wouldn't have expected much frontogenetic activity in our region. So I don't think the snow, yeah, look at how poorly organized the thermal structure is at 850 millibars. There's absolutely zero reason to say, oh yeah, watch out southern Wisconsin, strong lower tropospheric frontogenesis on top of the wave going by aloft. You get a big snow when that happens. But we don't have the lower level ingredient here at all. There's really no indication of that whatsoever. So that's quite interesting, but not poorly forecasted. That seemed to be true most of the week. There was never going to be anything substantial at 850. So let me just show you some interesting things I have on this. Thanks, Pete, for driving through there. Let's blow that up to the full size. We got to go to lectern HDMI, right?
Yep.
Okay. So here's the quasi-geostrophic omega at 500 millibars. I don't usually show the 500 millibar omega, but I do today for, just because I was looking at it this morning. So this is just where it's ascent. There'd be a couple of descent here too, but I didn't want to cloud the picture. This is from last night at 7 p.m. So look at that. The QG forcing is really strong and resulting in really strong upward vertical motion right over and to our west at that particular moment. So that's a pretty good amount of forcing for upward vertical motion. In fact, as I say, this is the upward vertical motion that exists at 500 millibars. Let's go to the next one. Watch how it progresses across the region. This is this morning, so it's a little bit more intense.
It's actually midnight.
Oh, yeah. Midnight, sorry, 6 hours different. It's more intense, the vertical motion is, a little more concentrated, and that's consistent with the development of that upper wave that we saw from 0 to 12Z. We're kind of intercepting it in the middle here, in between. So, really, still a little bit of ascent over Dane County at midnight last night, about 3 microbars per second, as opposed to 8 over southern Michigan at that time, but we started out around 6 or 7. So, the quasi-geostrophic omega in the middle troposphere was getting weaker as we went from the beginning of the snow to about midnight. But it didn't disappear, and I don't have 12Z. So now let's take a look at splitting this up. Actually, I should correct this. Yeah, this is the total. Sorry, it is. No, it's not. It's just the PVA NVA by the thermal wind. This is just the PVA by the thermal wind. Sorry. It's not the whole vertical motion. It's close. So here's the 500 millibar total geostrophic vorticity at 0Z on the 10th of March. The next slide will put the thickness from 300 to 700 millibars on top of it. You can go ahead, Pete. So that's the 300 to 700 millibar thickness. I mean, you can't ask for a better orientation of vorticity isopleths and thermal wind streamlines to produce a maximum of quasi-geostrophic ascent right over southwest Wisconsin. It's perfect. Okay, it's just you couldn't ask for more than that. And then I think I put omega from just the advection of the vorticity by the thermal wind. Yeah, I did show you the total omega before. This is just the PVA by the thermal wind ascent. So it's 6 instead of 7 units. It's almost the whole thing. But look at it, it's exactly where you might expect it would be, centered over southwest Wisconsin. Now, you can split that total geostrophic vorticity into its shear and curvature pieces, and then look at the contributions they both make to the total PVA by the thermal wind vertical motion. So remember, we're about 6 units over Madison of ascent at 6 p.m. last night, 7 p.m. last night. Here's just the shear, the geostrophic shear vorticity at 500 millibars. And throw the same thickness field on top of that. And you can tell that you're going to have still PVA, it's just shear vorticity, not the whole vorticity, occurring over the southwest part of the state. And if put the corresponding vertical motion, 3 microbars per second. So about half of what the total is from PVA by the thermal wind is accomplished by the shear vorticity advection. And look at how the shear tail looks a lot like that thermal thing we saw at the 0Z 500 millibar shot. So that's all consistent. You get this kind of salamander-looking or tadpole-looking vortex structure on the upstream side of the developing wave. It almost looks like an idealized model. And there's the vertical motion that corresponds to that. The other part of vorticity is the curvature. So let's look at that. That's the next slide. That's just the 500 millibar geostrophic curvature vorticity. So most of the curvature is in central Iowa. And we put the same thickness field on again. So there's PVA of curvature vorticity over southwest Wisconsin. What's the total amount of vertical motion? It's about the same, about 3 microbars per second. So at the beginning of the snow, this is the conclusion I've kind of come to in the morning. At the beginning of the snow, both contributions, shear and curvature vorticity, were kind of contributing equally to getting the show on the road here, about 3 microbars per second. Even though they're completely separate pieces, they add to the total that you saw before. What happens in the intervening 6 hours? Remember, the whole structure and the whole system is moving to the east fairly rapidly, so let's see what happens at 60. So this is now just the geostrophic shear vorticity at 60, so at midnight. Much stronger. Remember, the top value was something like 12, I think, at the prime time. Now it's 1.5 times that. And but the center is over Rockford, Illinois. So if we put the corresponding 300 to 700 millibar thickness on there, you don't really get strong advection of this thing anymore by this thermal wind, with the red lines or streamlines of the thermal wind. Over in Michigan, yeah, you get a big amount of advection, stronger than we had over Madison. Here it's kind of weaker. What does the shear vorticity omega look like? Yeah, the big bullseye is over here in southern Michigan. And here we are in Madison. Where's the border? There it is. So we're right about here. 3 units, so 3 microbars per second contributed by the shear vorticity advection at that time. So let's do the other part, which is the curvature. So here's the, is that right? Oh wait, that was the total, I'm sorry. Everything I just said was a little bit wrong. This is the total vorticity at 060, and then everything that corresponded was the total vertical motion from PVA by the thermal wind. So we go 2 clicks ahead, Pete. This is the total vertical motion. So we still had 3 microbars per second at midnight. And so we were kind of a constant snow rate most of that night. And I went to bed around midnight, waiting for my wife to come home. She was stuck in Dallas, as it turns out. So when I'm done here, I'm going home. So that's what happened. This is the total. Now we'll split it into the shear and curvature. Sorry, I didn't do that. Right, this is the shear. And again, it looks tadpole-like, but the whole structure is moved to the east. Let's put the same thickness on top of that again, Pete. And then the next slide will be where's the PVA by the thermal wind. And the maximum is right over that southwest part of Michigan. And in Madison, we're looking at the shear vorticity contributions about 2.5 microbars per second at 500 millibars. So a little bit of a decline from the shear. But 2.5 out of a total of 3, one gets the impression that the shear vorticity kept it snowing last night, shear vorticity advection. So the structure of that upper wave, being mostly a jet feature, was really contributing to the snow, is what I'm kind of beginning to think. And then let's go to the next one, Pete, which will be, I think, the curvature vorticity. Yeah, the maximum is over Milwaukee. So put the same thickness field on, you're going to see something you don't like if you like snow. We're in the region of negative curvature vorticity advection by the thermal wind. So curvature is shutting down the snow and revving it up over Michigan. We put the vertical motion on. See, all of the curvature advection of vorticity is way over here in Michigan. Madison's left out in the cold. So of the 3 microbars per second that seem to exist around midnight from this diagnosis at 500 millibars, almost all of it came from the shear vorticity advection by the thermal wind. And there's a little bit of erosion of the updraft because of the curvature vorticity advection, but I'd say it's closer to 0 there than it is something negative or contradictory. So that's kind of interesting, and that's what I have for the snowstorm. We started out with equal contributions from both types of vorticity in that interesting wave structure. As the whole thing progressed across us, the curvature part was too far to our east, but there was still plenty of forcing from the shear part of the long vortex strip, and that's what kept it snowing over midnight and probably gave us our biggest event of the year because it was those extra hours that did it. So I think one thing that could be interesting to look at too, and I did, but I didn't have it ready to report to you, is that one can also take a look at the transverse part of the quasi-geostrophic omega. That's always poorly representative of the frontogenesis that might actually occur in real life, but nonetheless, it makes no contribution here, just as looking at just the regular frontogenetic forcing from the 850 maps kind of suggested. So there's no particular forcing for frontal type vertical motions to overlap with this, which is going on at the wave scale. So this was all wave scale vertical motion that gave us this snow event. And particularly important to get us over the hump for the biggest one of the year, I think, was the advection of vorticity of the shear vorticity by the thermal wind. So that's all I have for the current weather. So and I'm not ready to say, but I will anyway. Maybe this is the last snow of the year. Who knows? Could be.
Other than Saturday night.
Other than Saturday night.
We haven't gotten the forecast yet.
Yeah.
There was a comment on the stream. Somebody asked if we could comment on the strong warming SST and actual very big precipitation in Peru and Ecuador. I don't know, and I asked if they could share a website. If they have something, I'll bring it up.
Yeah, I have no idea.
Yeah.
Can't say anything. Okay, Patrick, thank you again for taking the forecast.
Could we go to the weather.gov? So sometimes when I'm trying to figure out what to talk about, I go to weather.gov, which will pull up in a second here, and I look at the QPF, the quantitative precipitation forecast. So if we could scroll down to, keep going to the very bottom to current outlook maps, and then click on QPF. And let's see, so here, could we make this a little bigger by chance? Perfect. So this is a look at the quantitative precipitation forecast for today, basically from 0 UTC, which would be later this evening, to 0 UTC later tomorrow evening. So you can take a look at where it's predicted to rain. And I want to step through these maps and see if you can point out what I've focused on. So if you could just hover over day 1, day 2, very successively. So here's day 2, let's go to day 3, let's go to day 4, let's go to day 5, day 6, and day 7. So there's one region of the United States that's going to rain
Every day.
every single day, which is California. So if we could go to the total, this will be showing the first 2 days of quantitative precip. So we'll see there's a big bullseye over California, especially the mountains. Generally 1 to 2 inch rain everywhere else. Let's go to 1 to 3 days. Bullseye gets bigger. Let's go to 1 to 5 days. Wow. Even bigger. Now we're into 10 to 15 inches of liquid precipitation. Let's go to 1 to 7. Close to 20 inches of liquid precipitation over California. And this would be anomalous in itself, but this is particularly dangerous because California has already gotten storms over and over and over. So this is going to be a big problem if this pans out, and it's looking like it will pan out. And most of this in the mountains will be snow, but there's actually hazards put out. If we scroll up from this map, excessive rain is what I want to point out. You can see some of these 6 to 10 inch is going to be liquid, all liquid, in areas of California which have been in a historical drought but have received a ton of precipitation already. And so you get 8 to 10 inches on top of already wetland. Mudslides are going to be a huge problem, just on top of flooding, but this is hilly terrain. So, and we can go, this is day 1, day 2 has a risk, day 3, we can go to day 4, and day 5. So there's risk for excessive rainfall over California for at least 5 days, which will be a big problem. And so we'll go into why this might be the case. So
The type is going to matter too, as you point out,
That's
because
right.
the prior snowpack, if that's saturated with water, it's going to be a lot more dangerous than if it's just covered with new snow.
Yep.
Wow.
And I heard on the news on Good Morning America, some of this, all of this snow that has fallen is going to get rain on top of it, and that acts like a sponge, just soaks up all that moisture. And so they have 8 feet on top of roofs. You can imagine it raining. So it's already under stress because 8 feet of snow is heavy, but you get rain and then...
You can't run off, so it
No.
just adds the same
There's
water
nowhere to
mass
go.
again.
Yep.
Oh my God, that's amazing.
So this might become a big humanitarian problem
Yeah.
over California. We should watch that. But let's go to the Weather Watch links and we'll pull up our surface forecast. So that's what I picked up on when
That's
I
awesome.
figured out what to look at. Perfect. And we'll do the surface with 3-hour precip. We'll do the loop here. We can stop it once it loads. And let's go to we'll go to the current time. So we'll go to 18. You can see perfect. So this is the GFS look at the current time. Here's our storm system that produces our snow. We're in a region of, let's see, maybe some cold air advection, not too strong. But you can see there's rain and snow over the western United States, and there's a system that's actually going to develop and impact our region for Saturday into Sunday. So if we click forward here, we'll watch this system develop off the Rockies. Perfect. So we'll watch it just track over the Rockies into the northern plains, and this becomes a quick hitter of snow for us if we keep going. We'll watch it. So this is now late Saturday evening. We get into a snow region with the 540 line well to our south, and you can see it snows for a couple hours. So this might be a 1 to 3 inch snowfall range, but I picked up on it's noticeable because this is more of an Alberta Clipper type storm system. We've been getting these Colorado lows, deep moisture, warm snows. This will probably be a dry, light, fluffy snow. And usually it gets pretty cold in its wake. And if we keep going on this map, you'll see a high pressure sets up, and we get pretty strong cold air advection over our region that persists with this high pressure. You can see it we keep getting cold air advection, and this is now into Monday morning. We'll keep going here. I'm gonna watch, we just kind of sit in this cold air advection regime, or neutral temperature advection. So temperatures will stay cold until, if we keep going here, you'll see now we're into Tuesday, late Tuesday evening. Now into Wednesday, we get a low pressure system into Canada, and suddenly we get into a warm air advection regime. So spring break will be cold here until Wednesday, and we might get into the 40s but relatively cold. And if we could go back to the start of this loop, and if you just want to click consecutively, please, we'll just watch these slugs of moisture and rain just persist over California. And you can see there's some little disturbances that appear and track towards California, but it stays moist and raining and snowing over California. This is now 100 hours into the forecast. There's some places that haven't even stopped precipitating. We'll keep going. We'll just watch this constant slug of moisture into California. So
what's the jet look like
yeah, we can look
over
at that.
this period of time? Because these things are riding at a pretty low latitude. I mean,
That's
at
right.
this time of year, the polar jet gets as far south as it's going to get. So this is consistent with that. But boy, look at how extended that is.
Yeah, and if you want to click forward, you can just watch. It doesn't really move from what I looked at. It just stays consistently in the same pattern, maybe some little divots.
Any wave that develops drags the air up from the southwest, which is bad
Yep.
news. That's more humid.
That's right. But the position
Wow.
relatively did not change. This is now 165 hours from where we started. And
That's
it's
amazing.
almost exactly the same. Yeah.
This matches exactly what I looked at as most images from the West Coast. That zonal extension
Yeah.
and that latitude is the exact same. That caused like a week of rain in 2005 in San Francisco and $3 billion of damage.
Oh,
It's
interesting.
exactly
Yeah.
the same setup.
Yeah. The
I can
question is,
believe it.
what drives the persistence of that extended jet is a really interesting question.
Right. Exactly.
Man.
And if we could do the same thing at 500 feet, please. See, there might be some synoptic scale. Of course, let's stop and yeah, you can just keep clicking forward. So here's our disturbance. We can watch it move on towards the northeast. Here's our next system, our next snowmaker. Very small, but if you see, there's little slugs of just high vorticity, high positive vorticity that just move off the Pacific into California. So you have the terrain, elevated terrain producing, if you have moist flow, just lift, but you also have these slugs of high vorticity. You have a wave. This is now Tuesday, so you have a wave develop, so you're going to get even stronger synoptic scale ascent. And if we could just keep going, we'll just see these slugs of high vorticity just keep moving into California.
Yeah, there's a zonal jet that provides an environment of cyclonic shear over the whole central Pacific Basin. Central being, at the latitude of California, Oregon border. Any little perturbation that gets caught in that shear zone is going to have a potential to develop, and several of them do.
Yep, that's exactly right.
And I guess they must individually contribute to the maintenance of the extended jet. I have to think about why that might be, but I think that they do.
I believe that this would be a great case to look at, because this is 200 hours into the forecast where it just stays extended.
Yeah, it's really
For this
high
period.
impact extended jet. What really interesting. Well, one of the reasons why that it contributes is that, the cyclones will always go poleward because of the direction of the thermal wind when they distort the thermal field. So you're going to maintain low pressure at the end of the jet, at the jet exit region at higher latitudes. And then any anticyclones that might migrate on the anticyclonic shear side will do just the opposite. They'll go to the
That's
south.
right. That's right.
And so you're going to have that. It's hard to get rid of that pressure gradient
right.
once it gets extended all the way out there,
That's right.
if it's active like this.
And an
Really
anticyclone sitting, southwest of California, lower pressure sitting over Seattle, Washington, you just get a funnel flow and moist flow
Yeah.
from the deep tropics right into California.
I think
that's
that's
what's happening.
5760 geopotential height line hardly moves until you get to about Friday of this week. If you go through the whole movie, it's pretty much like a latitude line
Yeah.
for most of the week. And it dips farther south, well farther south than it usually is over Baja California by the time you get to the end of the week.
That's right.
Really wild.
And then if we could go to 850, this will be my last loop I'll show, please, Pete. From this, we can just click forward like we've been doing. So this is Hawaii. So even though projection looks like this might be zonal flow, this is actually southwesterly flow into California. And you see it just persists straight into California this entire time. And towards the end of this loop, you can see maybe some cold lows forming if we just keep going here. This is sort of the bigger snows they were getting at the beginning, where they would have a cold air mass sitting, low pressures developing. But you can see there's a Arctic outbreak of cold air from Alaska into the northern Pacific. And that was notable because this sets up a baroclinic zone. You get a wave moving over this baroclinic zone, suddenly you have a strong development.
Yeah.
And more snow and rain into California and the West Coast. So this setup does not look promising if you want to keep California dry.
Yeah, north of Hawaii, at this point, you've got a merger of the tropical air mass and the polar air mass and really strengthening that baroclinic zone. And that will stay unperturbed for very long. It just can't.
Right.
Looks pretty cold for us too.
Yeah, I would have said that out too. This is next Saturday, so, I mean, spring here will not feel like spring, but
Man.
yeah, it stays cold over us too. Just see, at 8:50, we kind of just stay in this
Full
cooler
spring on
maybe.
Wednesday or Thursday.
That's right, we get upper 40s potentially, and then right on in its wake.
Yeah, jeez. But when it makes those excursions southward at this time of year, when clear skies, that's the end of that cold air drop. It's going to disappear diabatically. So look at how everything's crowding up north of the North Slope in the orange and yellow. That's the only place you can stay cold right now.
Yeah. Right there. And then one last website, please, Pete. If you could type NRCS space USDA space gov and then space snowpack maps. This will show a look at the current snowpack, and it's the very first one here. Current snowpack in the west. And it's a very cool map. So if you could zoom in, and let's click basin conditions here. Top right. And then we can zoom out. So what this is showing is this is from 1991 to 2020, a current look at the snowfall, snow water equivalence deviation from normal. So everywhere where it's going to keep snowing and raining, you see we're at 200%.
Wow.
There's some 300%. This is 500% up here in Oregon. This is a very good signal if this was the end of the precipitation. But because we're keep raining and snowing over these regions, this is a bad signal. And what's really cool, if we could click on like this area, it'll pull up a little map. So if we could click this again, we'll blow this up. This is a really cool website. So this is a look at, these are the percentiles of the snow water equivalents here. The black line is where we currently are. So this is record for the 30-year averages for this basin. And this is consistent everywhere. I've clicked on, like 10 of those basins. Everywhere is above the record pretty significantly, and we're going to get, 15 to 20 inches of more precipitation over these regions. So that's why this is such a problem.
I want to go look at that 500 one up in Oregon.
Yeah, that one is a little suspicious because it only has one basin. If you click on it, it'll say like stations used,
yeah.
1 of 1, and the map is, this is where we are and this is the record. So I don't know how that one is
maybe
calculated.
green is normal. That green line must be like the climate.
Oh, potentially, yeah. But so this is, a very bad signal. We'll have to watch that going forward. But
That's very cool.
it's a very cool look at how we're doing. And it'll also pull up like snow depth, precipitation. So if we can do snow depth, it'll pull up.
Looks like a map of Europe and the Holy Roman Empire or something.
Right. Like Middle Earth or something. Let's try, I had to do this last night. Click precipitation. Sometimes the snow one just doesn't, there. So this is a look at the precipitation to average. So you see everywhere is pretty close to 100%, but California, Nevada, Utah, all well above 100%.
It must mean it's also a little colder than normal because the 200% snowpack and 100%, 160% rain. Maybe that's how you can interpret that.
Yeah, definitely.
Wow, that's really interesting.
So any questions or comments about that?
Are you keeping a list of all your websites? Because every week it's a new reveal.
Yeah, I go on my bookmarks and click that, and you just see it's a big long list.
Yeah, these are
Bookmarks,
excellent.
yeah.
Every week it's something new
Yeah.
and interesting. Well, all right. Thanks,
Yeah,
Patrick.
Thank you.
All right, thanks, everybody. We won't be here on St. Patrick's Day, but we'll be back on the 24th. Yeah. You're forgiven. Thank you, Pete.
Yep, have a good spring break, everybody.